that's Ivar introduced in Objectory. Was it in the Objectory name? And then later as a part of UML, also known as the Three Amigos. And of course, there are many other things you have done. So it's really a great privilege to have you here. And I remember you said, but all that's history. Let's look to the future.
Let's look in the future.
And that impressed me, really. That impressed me, really. So I will give you the mic, and I'm really looking forward for your presentation. And sorry for this room. It was in the last moment, and simply we couldn't find other room.
Okay, thank you very much. I can't tell you how excited I am to talk about. Actually, not so much about the 50 years, but so now what? 50 years ago, when we coined software engineering, I was an employee at Ericsson. I was a little younger than now, but otherwise it's not changed so much. I was actually responsible, it was unbelievable, but I was responsible for the most mission critical project at that time. And the reason I got that job is that I didn't know anything about software. But they thought I could run a project. We had no methodology. We had no software engineer. We talked about that we were engineers instead of programmers, which is quite interesting 50 years ago. But we were able to develop the most successful product ever in the history of Sweden. And it still is commercially the most successful. Over these 50 years, of course, a lot has happened. We could discuss, of course, we have done fantastic things. The interesting thing is that the most successful software companies today, you know, Google, Facebook, Amazon, and so on, they are known for software, but the reason they are successful is not because of the software, but because of the business model, the way they were able to create a business. And of course, their way of developing software didn't prevent them from being successful. So now, so what is software development really? Is it an engineering discipline? Or is it a craft? I think we all agree it's a little of both. However, look upon all the different competing methods we have today and have had over the years. And that people go into almost religious sects. I love this method. And everything else, they really don't know about the other, but still they belong to sects. And that we today have not so much tools, because during the agile era, tools were not really the technique. They wanted to do it's a craft. So I think we may be more of a craft than an engineering discipline today. Do you agree? Okay, a few. Do you disagree? No one dares. Okay. We are probably, but it doesn't matter. We are a mix. We need craftsmen. So how mature are we? Look at the history. From the 50s and 70s, most people were doing structural analysis and design. It was function and data. In the 80s, we started to do objects. Components came a little later. UML was at the end of the 90s. Rational unified process, or unified process in general, was very popular. That's when I was a guru. People thought I knew everything. And it was very hard to play that role because I knew how little I knew. And when we got CMMI, we got so many people went into CMMI camp. And when we got agile, first we got crazy agile, and then we got a little bit more mature agile, and now it's scaling agile with safe, DAD, less, and Nexus. So, but one thing we know, tomorrow we will have something else. And what is that? What will that be? All these techniques have something good, but so that's not the problem. So what is the problem? Ivica, can we make the screen a little bigger so I can see what I'm talking about? Yeah. Otherwise, I need to lift it up. And
I have also seen.
Okay, I can look here. Don't worry. I can look at here on the screen. Ivica, we don't have time for this.
Yeah, exactly.
So I look at the screen. That's good. So anyway, that's not the problem. So what is the problem? Here's some. We are in a methods war since 50 years. So why are we saying that? Because the people who create methods, they borrow from one another. They steal almost. They don't return anything. And they change because they think they can do it better. So that, and then they improve, and then eventually the original good ideas have been a little distorted. And that makes, of course, no one happy. If I have created a good idea and someone else just takes it and change it and don't understand really what's all about, I can't be happy. So that resulted in a methods war. Now we have these 4 or 5 methods for scaling agile fighting with one another. So now I need to explain the difference between the method and practice. A method is basically what we, in this talk, is what you need for a team, organization, completely to develop software. But the method consists of smaller things. For instance, component-based development, user stories, architecture, and so on, and self-organizing teams, pair programming. We call them practices. So a method is, and that was a very important discovery we did 15, 20 years ago, that every method is just a composition of practices. So that result in, since every method consists a number of practices, but they are not separate. You cannot take them out and say this is a practice, this is another practice, and so on. In some cases you can, but then it's described in the guru's own language. So you don't really can reuse it. It's very hard to reuse. Method prisons are controlled by gurus. People like me. and that is, you know, these people decide what should go into the method. And they cannot possibly know everything, but still they do it. And people form sects around these methods. And they say hurrah to everything that the guru does. It's a completely crazy situation. So we need to get rid of the gurus. And all methods are monolithic, meaning they are one big thing and not really separable. You can probably separate, but it's hard work. You can definitely not reuse what others do without rewriting. And that is what method gurus does. They rewrite and misunderstand. Every method's description is homegrown. The user experience for a method is it's homegrown. SAFE has its user experience, DAD has its, RAP had its, and so on. They are all developed by basically the guru and his team. And then it's not only that, it's the structure, it's the terminology, vocabulary is different. This after 50 years of software engineering. Methods have no common ground. Not quite true, but we have very little common ground. Of course, we use techniques. We use programming language, operating system, database management, etc., etc. But we don't have anything we can say, this is software engineering, more than possibly a 4-line definition. So that's, okay, I know I'm to some extent a little exaggerating, but not much. So if you want to get deeper into what I'm saying, there are 7 papers published in CACM. And I hope you take the time to get deeper. This is not very professional to say, but this is how I feel. It's immature and foolish. Thank you. Everybody. Okay, so what do we need to do? We have these problems, and how we go to attack them. First thing we need to do is to discover a common ground. If we have a common ground, the homegrown idea will disappear, and we will have something that we all understand. Second, we need to modelize them. But modelization doesn't mean necessarily componentization. There are other ways to modelize, and we have selected another way. And we need to free the practice from our methods. It means that the practices in the methods should be extracted and described in such a way that you can put them in some kind of ecosystem, and you can get them, take the practice you like and put together to a method that you need. That will also, if not end the methods war, it will make it less dominant. We probably will always fight about practices, but that is at least on a technical level. Today, when we compare methods, it's 80% marketing. The successful methodologist is a successful marketeer. Yes. I think that was my problem. So if we look at the first thing, how can we find a kernel? Well, in 2009, we created a community to do this job. It's called CMAT. It was Bertrand Meyer and Richard Soley and myself. We got hundreds of people supporting it, thousands of people. And hundreds of people have worked on this project. So we were set out to create a common ground. We have, we call this common ground essence, basically the essence of software engineering. In the essence, we only wanted things that no one could say, I don't need it, and I don't need to think about it. So we were very conservative in what ended up in Essence. Essence consists of a very simple language. It's visual, of course, intuitive, if I may say so. The kernel are the elements that we always deal with when we develop software. The things we work with, the things we do, and the essential competences we need to have. And that became the common ground. In 2014, after 5 years of working in this community, we got it adopted as a standard. I mean, I'm not necessarily a big fan of standards, but I think there are some things we absolutely need to have as a fundament. Otherwise, you cannot trust what to do. So, a little about the language. It's very easy. Practices have this notation. You describe a practice, it has activities, things you do. You have work with something. The most important things you work with we call alphas, because there was no term in the whole history of software engineering that were applicable. So we had to come up with something, and it was, so the most important thing, alpha is the most important letter in the alphabet, at least the first one. But what is alphas? I'll come to it soon. But alphas is nothing you can touch. Instead, the touchable thing, tangible, are work products, documents, and similar things. So you write work to products. But as we know now in the agile world, we do develop a lot of things without documenting it. We don't always write down the requirements. We keep requirements in the head, and that's fine, perfectly fine, in small teams. It doesn't work for large organizations, but it works in very small teams. So documentation can be very light, but we still have requirements. We still have requirements even if we keep in our head. These, so I'll soon get to it. We have also competences. To do a job, you need to have a certain competence. So this is basically the language. There is a little bit more about it, but this is basically, it's very simple. You can learn it in, say you learn it, the whole language in a couple of hours. Then, on top of the language, we now describe the most important things we deal with when we develop software. These are what we call alphas. And we have customers. In the customer area of concern, we have basically 3 areas of concern. One of them is customer area. We have to think about what the client needs, or whoever the client is. And there is one alpha there, one key element, namely the opportunity. Why do we do this? Because there is an opportunity. Someone has a problem or opportunity to address. There are also stakeholders. We develop software for users, and maybe someone wants to make money. We have to think about that guy too, and so on. We have another area of concern, and that's the solution. In the solution area of concern, we have 2 things to think about. We have requirements to be met. Now, don't take that as we know what the requirements are, but there are requirements. They will grow as we know more about the system. And we have a solution, software system that we build. Then we have the endeavor, the project area of concern. And we need to kick off work, so we have work. We need to build an empowered team. And we need to have a way of working. So these are the 7 most important things to think about when that is generic to all software projects, at least according to hundreds of people and according to a standard. Now, the standard is such that you can add to it, you can simplify, and so on. It's very flexible. Now, what's interesting here, these alphas have states. So if you think about when you work, you have to progress through states. You have to, if you look upon the software system, the first state here is that you need to have an architecture selected, because if you don't have an architecture, you will have to you need at least have a proposal for an architecture. Next state is that you can demonstrate something becomes usable. So these are state progression that you do when you develop software. When it comes to opportunity, you have an opportunity that is identified. You identified the opportunity, you found that there is a solution, and so on. So the only thing we know about alphas is that they have states. And you can attach to an alpha work product. So for instance, requirements. To requirements you can attach a requirement specification, or a use case model, a use case specification, or user stories, or whatever you want to them. So work products are not part of a standard. What is standard is that there are requirements, and they can be progressed from state to state, and you have to progress them, and that you can attach to them some work products. Every state has a checklist. So for instance, opportunity, the first state identified, there are 3 different things, criteria you need to reach to be able to say you have identified the opportunity. So these are the progress from state to state that you do. And when you work with all alphas and progress them in some waves. So and these waves are balanced. That's how you progress development. Let's go to the next point, modelize the methods. What does that mean? At the bottom, you have the essence kernel and language. On top of that, you have a layer of practices. And some practice can be built on top of other practices. You have generic practices, such practice that can be used in many different methods. Or you have specific practice for methods, specific for DAD and SAFE and so on. And at the very top, you have methods. Here you have these 4 methods designed by composing practices. Actually, the interesting thing, these methods that look very different if you read them, they have a lot in common if you do like this. And that is totally hidden to us. We don't see this commonality. It's hidden. And you can not only design these methods, because now you have, you can take practices coming from DAD and SAFE and so on when you create your method, not only from one domain. So this is here is an essentialized method. It looks like this. It has the essence kernel at the bottom, and then it has practices on top of it. That is a method. Imagine now you have a practice ecosystem with 4 different set of methods, 4 different methods. If you now have an ability to say, I need to select a method, and not all practice I want to have come from SAFE. So then you can do like this. You select the practice you want to have, and these are the red ones. You throw away the ones you don't need, and you have your own method that your team can use. That is something we cannot do today, something that I believe every organization wants to be able to do, to be able to find the method that fits you And that method comes from not only one source, one guru, even if that guru is very good, comes from the whole world. And anybody can identify new practices, put in this ecosystem, market it, and get it reused, and maybe make some money. So not bad if you can make a little money. So what is it that we get with all this? I separate the value proposition for industry and from academics. So starting with the industry, what value is this to the industry? Every team can select their own preferred method. They can do that today, but it's hard. Now they have to rewrite to put it together. Here, with this, they can take practices and do the job of merging. Merging is not trivial, but there is a very systematic way of doing merging of practices. This is wonderful. This is what we all dreamt about, to be able to select the method by not going to a guru and say, I want your method. You want to select the best things you believe is best for your team. You can measure progress and health of your project or your team's work without in an agnostic way. So even if you're a project manager, you have 20 teams and they are allowed to use the method they think is the best, how do you understand where the teams are today? The team will tell you, well, we did this thing and we have done that activity and so on. And you are just, okay, you don't get a clear picture. So now with this you can measure in an agnostic way, because when we measure outcome, we don't measure if you have done an activity or done a document, written document, we measure real outcome. We can, this is another thing. If you work in one big company and work with one single product there, if you want to move to another part of the organization, you have to relearn what you already did, because they use a different terminology. Now we have a basic terminology that is a base for every developer. This is fantastic. I mean, I remember when I had worked 15 years at Ericsson and moved to another department, and I was very experienced compared to all the people there. They were newcomers, basically. But I had to sit 3 months to learn the new language. Have you experienced that? So it's not only me. Good. And then, since you have a repository of and an ecosystem of practices, people go to this repository, take out practice, use them. Now they can go back and improve the practices. They have somewhere they can go and improve. You get a forever learning organization. Today, there is nothing similar to this in the big companies. Finally, your organization moves from primarily being based on a craft to primarily being based on an engineering discipline. Why? Because there is systematic. You improve. You can build tools in a way you couldn't do before. So this is the value proposition for industry. If you go to the academics, students learn what is generic to all methods, not just specific methods. Most education in software engineering today means that the students learn a particular method. And then they use that in projects at the university. When they come into the industry, they will certainly not use that method. And they discover they have a terminology that the company is not using. Here, with this, they learn a foundation that is good for basically all methods. And particularly if this is implemented. And then they can learn specific methods by using this common ground, so they can compare methods. They learn game playing. Okay, one thing I forgot to tell you. What do you think this is? What do you think this is? Deck of cards. What do you use the deck of cards to? To play games, to play serious game, to develop software. These are used in the daily work. And so basically, the whole kernel is described on 50 cards, like this. And they are the things you bring with you after the class. So you learn more in the class, but this is the essence. The essence is about, I used to say it's about 5% of what an expert knows. But this essence is what you need when you start, and you can participate in projects thanks to knowing these things. And then, for instance, Scrum is now essentialized, as we call it, on 23 cards. And we don't do this without the help of the founder, the creator of Scrum. So Jeff Sutherland, who is one of the two creators of Scrum, he has worked with us to develop 23 cards that he used daily in his training. Imagine, he has trained Scrum for almost 20 years. He has routine. He has been incredibly successful. They have trained 500,000-600,000 people in Scrum. Not only we, but others. And still, we come and show him these cards, and he say, wow, this is what I want to use. So he uses it now, today, in the daily training. DAD, Scott Ambler, is just about essentializing DAD. There's work going on. So students will learn software development by playing games, which are serious games. It results in software. And now researchers have got something, a standard model for what software engineering is. It's one of the things that has surprised me. We are doing so much research in software engineering, but we don't have anything that is a base for what is software engineering. The only thing we have is a 5-line definition of software engineering. And of course, we need more. This is just what is called a descriptive theory of software engineering, what we have. What we also need is a predictive theory. But we are on a way to get a theory in software engineering. So, what are we doing? I'm getting to the end now. In the industrial world, we have companies that have been using Essence for many years, and they are just growing the usage. Tata Consulting Services are essentialized, saying they have essentialized all their methods. Tata, how many 100,000 employees do we have? 300,000-400,000. They have essentialized all. And Red Hat has used essentialized practice for engagement. So it's not about software development. They use the kernel to describe an engagement with a client. In Sweden, there is a project, Open Innovation. They have developed a method for doing innovation consisting of 7 or 8 practices. Has nothing to do with software development, but they use the kernel, Essence kernel, as a foundation to describe these practices. And I've already told him that, Jeff. And in the academic world, Pekka Abrahamsson, I am sure many of you know about Pekka. He's a prominent guy at this conference. He said, we have successfully taught software engineering to 460 students. We have finally moved beyond Scrum and Kanban. My software engineering education in the future will be driven by Essence. Many universities around the world are teaching it. And we have a project now with 50 university teachers from around the world participating. 25 are active. They are developing training. We have a book that is now in the 5th draft, taking care of 800 comments from 25 reviewers. And the book is 5th draft, it's soon published. The book is accompanied with training material, with exercises, and with games, 20 games that people can play with these cards. So this is going on. If you're interested and interested to join the project, you're more than welcome. That's the only sales pitch I do. So, but what next? What is coming next? I'll save the best to the end. Now when we have been able to codify practices, we are at the beginning of building smart practices, meaning AI. 20 years ago, almost, 2000, I founded a company that built intelligent agents to support software development practices. We had practices for use cases, architecture, and so on that were supported by intelligent agents. It became no success. It was the totally wrong time. This was the beginning of Agile. And in the Agile community, it's all about craft. At that time, Crazy Agile was only about craft. No tools can really help you. And but it worked extremely well. We cut down the cost of doing requirements at Föreningssparbanken in Sweden with 40%. And that was just the beginning. There's so much we could have done. What you can do, you can create an intelligent agent to do use cases, do architecture, iterative planning, and so on. And you get active guidance. It doesn't mean that you don't, the developer has to control it. The developer is the creative. But there is 80% of the work when you develop software is follow patterns. So once you have decided I'm going to do that, it takes time to do it. And that can be done by intelligent agents. So I believe 20 years ago was too early, but I still believe we can do it, and now more than ever. So finally, we are AI ready. So welcome to the future. Thank you very much.
Thank you very much.
Thank you, Ivar. Thank you.
So we are kind of running a problem with time, but we can do like that. People who wants to go to the break, go to the break. At 4 o'clock the next session starts. If you wish, you can stay here a while and they can ask you questions.
Those of you who have interest to ask any questions, of course, I'm more than happy to answer, because I know that many things I said are statements that has to need explanation. So.
Telstra försöker införa Scrum. Problemet är att integrera utvecklingsmetoder med finans.
Okay.
Hur man kollar att kostnader